What is the sum of all the solutions to the above equation? All right, this is interesting. We have 3 plus the square root of 6m minus 26 is equal to m. So anytime you have a radical equation like this, it's a good idea to try to isolate the radical. So, or at least to try to isolate the radical first. So let's try to subtract 3 from both sides to just be left with just the radical on the left-hand side. And so 3 minus 3 is 0. And on the left-hand side, you're just left with the square root of 6m minus 26. And that's going to be equal to m minus 3. Now, to get rid of the radical, we can square both sides of this equation. So we'll square that side, and then we can square that side as well. And so the square root of 6m minus 26 squared, that's going to be 6m minus 26. And then m minus 3 squared, that's going to be m squared minus 6m, it's going to be minus 3m plus 9. And if this step you found a little confusing, I encourage you on Khan Academy to review multiplying expressions, or I'll do a quick primer right here. M minus 3 times m minus 3, that's the same thing as m minus 3 squared. You'll have m times m, which is m squared, m times negative 3, which is negative 3m, negative 3 times m, which is negative 3m, and then negative 3 times negative 3, which is positive 9. And the negative 3m plus the negative 3m, that is negative 6m. And I encourage you, especially because on the SAT, you would have to do this under time pressure, to be able to do things like square a binomial like this very quickly, to realize it was going to be m squared plus 2 times the product of these. The product of these is negative 3m, 2 times that is negative 6m, and the negative 3 times negative 3 is positive 9. So now let's see if we can solve for m. So let's get all of our everything on the right-hand side of the equation. So let's subtract 6m from both sides. So I'm going to subtract 6m from both sides, and let's add 26 to both sides. And the whole reason why I did that is to just clean out what I have on the left-hand side. So on the left-hand side, I'm just going to be left with 0. And on the right-hand side, I'm going to have m squared minus 12m plus 35. Or I could write m squared minus 12m plus 35 is equal to 0. And so let's think about the m's that satisfy this. Well, I can factor this if I think about, well, what two numbers have a product of 35, but if I were to sum them, I get to negative 12. Well, 35, I could think of 7 times 5, but 7 plus 5 is positive 12. But what about negative 7 times negative 5? Well, their product's going to be positive 35, and negative 7 plus negative 5 is negative 12. So I could factor this into m minus 5 times m minus 7 is equal to 0. And if this step does not make sense to you, where I factored this quadratic, but if I have the product of two things that equal 0, that means that one or both of them need to be equal to 0. So m minus 5 could be 0, or m minus 7 would be equal to 0. Well, to make m minus 5 equal to 0, you just add 5 to both sides. You would have m is equal to 5, or same thing over here, add 7 to both sides, m is equal to 7. So the two solutions are 5 and 7, and if you want the sum of all the solutions, it's going to be 5 plus 7 is equal to 12. And if you just want to verify that these actually work, try them out right over here. 6 times 5 is going to be 30 minus 26, which is 4. The principal root of 4 is positive 2. 3 plus 2 is equal to 5. It's equal to m. And if m was 7, this is going to be 3 plus the square root of 42 minus 26 is 16, and this needs to be equal to 7. Well, the principal root of 16 is 4, and 3 plus 4 is indeed equal to 7.